Okay, so I've had a request for some help with the homework, and I'm looking at exercise 510. I think we began question 5 in class, so I'll just show you the solution there. Just check out, make sure you understand why I've put the quarter in front of the sec squared, x on 4. I need that to proceed. I have to have the derivative of what's inside the bracket of the sec squared function to proceed. So if I whack in a quarter there, I have to make sure that this is still the same integral, not some other integral, by times in by 4. So then I can put the 4 back in here. That was out the front. The quarter was just used for me to proceed. And so I've got 4 tan x on 4 between pi on 2 and pi on 4. So I substitute those values in. And then because there's a pi on 8, that's not one of those exact ones that we know about in 2-unit mathematics. So get to our calculator and plug it in. And we get 1.66 to 2 decimal places. Let's have a look at number 7. So we're doing the volume. You know that formula that's on your sheet for volume? There it is. So we have to square our function. So when our function gets squared, it ends up looking like that. And we're going to do that between 0 and pi on 6. You can see in red, the 2 and the half. I need to do that to be able to proceed with my integral. Once I've done that, I have my integral. Primitive, I should say, and then I have to integrate that between 0 and pi on 6. So we're going to do that between 0 and pi on 6. Now, there's a little trick I've done here. I'll just highlight those for a minute. See how here I've got the pi on 6 here, but now I've got it down here at the bottom, and over here I've got the 0 here, and then it went up to the top. Why did I do that? I can do that when I swallow up a negative. So if I get rid of that negative and now make it a positive, see there's a positive there really, then I swap the limits of my integration. So that's a handy thing to do. So now, oh hang on, for some reason it's... So now what we do is we plug in to our limits. Cos of 0's 1, cos of pi on 6, you go to your exact value triangle, root 3 on 2. So I've put that in, and then I've gone and got a common denominator, and there's your answer. So let's have a look at number 8. No, that's for 3 units, so I'll whiz past 8 and 9 because they're for 3 unit or extension, unless someone asks me for it. And here's 10. With 10, I want the exact area enclosed, so it's got to be closed up. So we're not going to use anything. See how this is open here? So that's not an enclosed area. So the only enclosed area is the yellow. Oops, what happened there? Find it. Oh, there it is. So the only thing there is the yellow. So I'm going to find my points of intersection, and y is equal to half and y equals sine theta. Where are those two going to intersect? And this is what I'm looking for here, these points here, there and there. I want to know their x-coordinates. So we solve that knowing what we know about right-angled trig of and the ASTC circle, and I get pi on 6 and 5 pi on 6. So that would be pi on 6, and that would be 5 pi on 6. So they're now my limits of integration. I'm going to do that integral from pi on 6 up to 5 pi on 6 of sine theta minus a half. Remember, it's the top function, and sine is the top function. I don't know why I've got a theta there. That's really weird. It should be an x. Let me fix that up. was just using thetas over here when I should have been using x's, but it's still good. So I've got the top function is sine x. That's that one there on the top, right? And the bottom function is y equals a half. So that's the bottom function, and there's the top function. We do the integral and then sub in. So there's the integral, and I've subbed in, simplified it, and there's my answer. Now number 11, you might want to pause the video if you want to check that. Number 11, I need the enclosed area between cos and sine from 0 to 2 pi. So it's open here and it's open here, so we're not using those bits. But the yellow bit is enclosed, so that means I need to find the points of intersection of sine x and cos x. So that's what I'm doing over here. So sine x equals cos x, divide both sides by cos x. That means sine x over cos x equals 1, which is the same thing as saying tan x is 1. Solve that, and I get pi on 4 and 5 pi on 4. So that's where the pi on 4 goes here, and the 5 pi on 4, that's there and there. Okay, so let's actually do that integral now, and we will find integral of sine is minus cos, integral of cos is sine, so, and there's a minus between that. Figure it out between 5 pi on 4 and pi on 4. Make sure we get all our minuses in the right spots, so you might pause the video to look at that. And, oh, that's erased it. Sometimes my electronic pen wants to erase everything, so that should be a 1 over root 2 plus a 1 over root 2 there. So that means I've got 4 over root 2. Alright, then I multiply top and bottom by root 2's to rationalise the denominator, and that's your answer for the area. Okay, have fun with that.